All right, we're into day 10. Just opened up. Let's click in. Today is pipe maze. Standing in a field is densely packed with pipes. Our puzzle input is a quick sketch of all the surface pipes we can see. Two-dimensional grid, vertical, horizontal, 90-degree bends, ground, starting position. Based on the acoustics of the animal scurrying, so there's an animal running through the pipes, we're confident that the pipe that contains the animal is one large continuous loop. So, okay, so it's just a loop. Okay, so, okay, interesting. Unfortunately, there are all many pipes that are not connected to the loop. The sketch shows the same loop. Okay, so we need to figure out which pipes form the main loop. Feels like the same cycle detection that we were getting into the other day. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, which is assumed to connect back to those two pipes. And these characters are really not helpful. So F is a right angle, right? J, F, 7, L, 7, J, F. Okay, so this is one pipe connection, I guess. So one thing we could do just off the bat, thinking about this, is if we use pet graph and we put everything in a graph, actual graph, then everything will just be connected when we insert it. We could also keep track of the positions like we did the other day and the openings and do the calculations that way. So like this would be 0, 1, 2, 2, 0, and it would have openings to the right and the bottom. So if we were here and we wanted to go right, we would increment by 1. So that could be a whole like instruction set. Let's see what we actually have to do first though. If you want to get out ahead of the animal, you should find the tile in the loop that is furthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. So not grid distance, I think. Not like, I guess Manhattan distance would be the... Instead, we need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. So in the first example, if we start in the top left, that means the bottom right, correct? More complex loop, we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay. Find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the furthest? Okay, I think we can start with the B-tree map then. Well, yeah, we could do the B-tree map and we could go in a number of directions. I guess there's only 2, right? These are all, it's either vertically connected, which is 1. Technically, they're all connected by 2 places, so left, right, up, down, etc. This is a ground. We can ignore that. S is the starting position. So I think S is the only place at which we could fork off. Theoretically, we could do like S in 4 directions, so we could have up to 4 routes going at the same time, assuming that there was like a pipe above, for example. Let's look at our input. That's not fun to look at. Let's not look at our input. Okay, if I zoom out, we can see it, and our input has only 2 outs. So I think we're good with making that assumption that there will only be 2 places to go out of everything. And for S, we just need to figure out which ones those are, I guess. So we need to keep the grid positions, and we need to know how to get from one end to the other. So this is definitely coming into an enum for sure, because there's no way that I'm reading F's and 7's and J's correctly. So we can set up our tests first. So just create day 10, get into day 10. I think this will be rstest, and we'll stick input in as the first argument and the distance as the second. I forget what the distance was on this one. 4. And then the more complicated loop is 8. Of course, we need to bring rstest in for those macros to work. And here we need to do what hash case. I forget what the syntax is here. Yeah, hash square bracket case input string slice. Let's just make both of these string slices, I suppose, because that's the answer that we're going to get out of our process. And this will be a process test. So we've got our test case. We've got both grids, the simple one and the complicated one. We've got a test using rstest. So for each test, we do input and output. Input goes into our process function. Output needs to match the output of that process function. Everything's good. So step 1 is definitely getting these into an enum. So all of these, okay, so we've got vertical, horizontal, northeast, northwest, southwest, southeast. I guess we'll keep our starting position too, so S, and then we'll just not do, I need to keep these characters around at least a little bit. Are we gonna do this? So if we write a nom parser and we use car, I know I'm writing this outside of any function right now, but this is the way that my brain's working right now. So outside of car, we can get any of these cars. I guess we also need S, and we also need dot. We don't technically need dot, but it makes writing the parser a little bit easier. We can always move it out later. So we get alt here, right? And alt is any of these, and then we map over that to get each of our enums. So let's do parse grid. This is going to be a nom locate, but I'm going to start off with a string slice just to get this running. It's going to be nom locate for a very specific reason so that we can easily get the locations of these. And then I think we want a B-tree map here. The question is, what is our B-tree map going to include? And I'll just make it 2 string slices right now because I'm not sure yet, just so that we can write the parser here. And then I'll do to do here so that that's done. This is going to take the input at some point, input, and I don't know, I'm just going to call it output for now. Get everything imported, get everything brought into scope. I think I'm going to, because car is a keyword, I do like to do complete car instead of doing just car. I do the same thing for the I64s and like the U32s and stuff. I just don't like having identifiers that can overlap, even if they are in different namespaces. So we do have to handle the error here, and then our destructuring will stop erroring out. This is only 1, so this is going to have to be many 1. And of course, this is going to allocate for the entire vec or the entire input. I'm not concerned about that right now. We can always go back and make it more optimized. I'm mostly concerned with solving the problem right now. So many 1, alt, any of these, all of these need to be mapped over, and we don't need to actually look at any of these values. There are, of course, 2 ways to do this. We could do our pipe in this map like this, or we could use the value parser. I tend to like mapping instead of using the value parser, but it's really a personal preference. And this is southwest, and this is southeast. This is starting position. And notice that I'm just, I'm not typing all of these. I'm just auto-completing all of them. This one isn't in our enum, so I'm just going to call it empty for the moment. I guess we can call this ground. Ground is the right way to phrase that. Of course, the map function on parsers is only on the parser trait, and the parser trait needs to be in scope for us to be able to access the map function. So that's that. So now we have, I think, a full parser that will take out the entire grid. So let's get parse grid here running on our input grid here to do this for later. And then our enum. So if I was going to work on this, you'll notice that I do a lot of work when we're doing these kinds of things inside of my editor with Rust Analyzer. I also like to keep the side process running, but I don't specifically need it. I've written enough Rust at this point where I can look at things like the squiggle on this output and know that I didn't implement debug for this debug macro to work, so that this is what I was going to need to do. But Rust will show that to you anyway. This looks like it's panicking. Got ground. That's not right. Is there anything we're missing? Let's debug the input too. And our input looks like we're missing new lines. So we have 2 options here. I think what I'm going to do is add an optional space to everything. So we can do a terminated here on the alt and do what, multi-space 0. So this will succeed all the time, basically. So we need to import terminated. So you can see that our alt is the first one in this terminated, and then multi-space 0 is the second one. So that should fix our new lines issue at least. It looks like that does fix our entire thing. So now we need to work on, well, there's 2 things we can do here, right? One is I kind of want to skip the ground. So I think I'm going to use is not instead, but I want to keep all the different variants of white space. So maybe it doesn't matter. Technically ground is part of our grid. So I'm just going to work with this for now. So we've got our vec here, right? And we need to get the locations. And I think we did that in day 5, if I remember correctly. Not day 5. Which day did we do? Was it even earlier than that? Okay, here we go. Day 3 was the day we used this stuff. So we can take this function that we had last time and we mapped over everything with it. And located span comes from nom locate, which I don't think we have in our current cargo toml. So I'll pull that in for sure. And then we want glam as well, because we're using that for the locations. Although I don't know that we're really going to make interesting use of that today. So we've got nom locate located span, which we need. We need the ivec2 with xy is kind of something we already wrote to get the grid positions. And that sits the xy stuff in our extra. We're going to need this type definition, which I feel like we have 2 options here. The way we did this in day 3 was to take this value type and return this value type with the extra information. And then when we used that, these values had the number encapsulated in the enum, but we're going to have this for everything. So maybe we make this a struct that is called pipe info. And then we keep the span around. We call this pipe type. Of course, that means we do need to use this lifetime here. And these are going to be invalid because they're not pipes anymore. They're pipe types. In this case, I do want to build this up from the base. So we're going to use .map with xy. And it's just going to be very verbose, but it's also going to be very simple because this is going to take that span. These, of course, are going to change into spans. Of course, our input needs to be span new, so that comes in correct. We've got a type mismatch, and I wonder if that's because if we do a .map here and we get some value, right, something that doesn't matter, we get a car here, not a span. So maybe we just don't use car for now. And if we use tag, then we get our spans. Then our function, helper function works. And that's just because I wrote this as span. That's it. That's because I chose this function to have a span, and I'm choosing to not write additional code for car, and I'm choosing to go with what we wrote already. So see, we can see the located span, offset 29, line 5, fragment, nothing. Looks like our parser has not failed. We're getting everything. And then we're throwing away the extra information that we actually want. So right where we're doing this, I think we need to construct the pipe info. Of course, I need to take all of these underscores here and pull that span out. And it is verbose, but it does get us all the information we need. I'm sure there's a better way to write that that's more concise. I'm not terribly concerned about that right now. So now you can see that for pipe info, we get the span, which has all the location information, including our extra ivec2 here, and then pipe ground. Now, because I chose to return this struct, we could keep this extra information out and kind of just get rid of these spans. So we actually don't need span here. This could just be ivec2, but I think I'm going to keep it. I kind of like having it, and it's not hurting anything. So in the future, we could, if we were trying to optimize this, trim it down, we could get rid of that because we already have our ivec2, but I'm going to keep it around for now. I don't think our input is that big that it's going to really matter. And we're going to build up a B tree map here anyway. So with our output, right, we're going to iterate over this. And what are we going to return? We have to decide what our return type is here. So do we want to access? I think we have to access by ivec2, which means we can't actually use B tree map. We'll see why in a second. I'll show you the error. But we're going to do ivec2 to, I guess, pipe info. We're going to keep the whole thing around, right? Really, this lookup only needs to give us pipe type, right? At a specific location, we have a pipe type. That pipe type is going to tell us what to look at next, which we can get through an ivec2. So I think all we need is the pipe type here. So we're going to consume this into iter. We're going to move everything. We're going to map over this with our pipe info. We're going to turn this into a tuple, which is going to be the pipe info.span.extra. And again, I'm keeping around the extra information here in case we need to debug anything, but you could write this in a much more optimized way. And then we collect, and this goes into what? Okay, input, output, collect with the all the parens that it needs. And what is the issue? The issue is going to be that B tree issue, right? The trait ord is not implemented for ivec2. So B tree maps, they are ordered by default. ivec2 doesn't implement ordering. So because we're using ivec2s as our keys, this is going to have to be a hash map for us. That's totally fine. It doesn't make a difference in our case. So here we're going to get our grid. And I showed off debug assert equals for input before, and somebody mentioned all consuming. So if we look at all consuming, we can see succeeds if all the input has been consumed by its child parser. So this is fine. It turns basically empty input into an error. There's another way to do that as well. Returns its input if it is at the end of the input data. So we could do EOF at the end, right? If empty, then EOF. I think it's really a matter of taste. But because it was mentioned in the comments, we're going to use it this time. All consuming many one. We do have to bring it in scope. Nom Supreme has a slightly different approach to that. Okay, so now we have a bunch of stuff. I kind of want to filter out the ground. Ground is a little bit of noise for us. So I'm going to filter map here. If pipe info.pipe type is pipe type ground, none, else. Well, we could do then some, right? We do then some here. This becomes if not equals. We don't need the if on the front anymore, although this does need to be wrapped in parentheses for it to work. We didn't implement equality here for pipe types, so I'll do that quickly. Eq and PartialEq. Eq is just a marker trait for total equality, so like we have a full set of things here. We don't have not a number, we don't have undefined, we don't have things like that. So we do have a total equality in the sense that everything here can be compared as equal to something else. There's also partial equality, which is the derived that actually handles the equality comparison. EQ is just a marker trait. It doesn't actually implement anything. So now that we've written this large parser, we now have everything, I think. And if we iter.find, is going to be key value, pipe type, starting position. Let expect should have a starting position. These are references, double references. I'm going to use underscore before key to get rid of the fact that we aren't using it. I am going to use underscore before input to get rid of the fact that we aren't using it. This is one of the things about all consuming that I was thinking about earlier. It doesn't get rid of the fact that we are returning this input from that function, which is totally fine. So we have an ivec2 pipe type for our start position. Let's make this a find map. We're going to return the key. Of course, find map is one reference, so we bring the reference down, and then now all we have is a ivec2. So we have our starting position. We need a loop now. Actually, we need two loops. This first step is going to be a little awkward because we have to detect what's next to it. It's not telling us where we can go. So we're going to do 4 gets here. This is going to be a lot of if conditions. I feel like doing the graph is easier in terms of this iteration because thinking about this, right? What we're going to have to do is check for 4 positions, right? For those 4 positions, depending on which side it's on. So let's say we check east. If we are checking the east of the position that we are currently in, then we need to make sure it is either a northwest or a southwest or a horizontal. I guess it's not going to be that bad. There's only going to be 3 options here, and we were going to have to figure that out anyway. So let's keep going with this. The first thing we need to do is get all 4 positions. It matters which side we're on, so I'm just going to do this manually. So we've got north, south, east, and west, and this is -1, this is southeast, and this is -1. So now we've got all of the positions. I believe the only issue here is that we have references on the left-hand side, which is totally fine. We can dereference these, and we get new ivec2s for each position. So now the question is, we need to get for each of these positions. And it's possible that there could be nothing because this could be a starting position in the top left corner or the bottom right or the top right or the bottom left or whatever, right? Or any of the sides as well. So any of these could be nothing. And basically we're going to write out the logic manually and then we'll pull it back into functions probably on the ground type, I think. So let's start with north, right? We need to do grid.get north, first of all. This needs to be a reference because that's how that works. This could fail. If this fails, we don't care, right? So let's start off with let next positions equals some vec of nothing. We'll make this mutable because we're going to push into it. And I'll make it clear this is a vec of ivec2s. So we've got our north position, right? And I think what we're going to do is find map, right? Well, we don't need to find map. We need to is some and here. And this is going to be a pipe type, which we can confirm by checking the type there. That is a pipe type. Let me get rid of that is a pipe type. And we'll match on pipe type here, fill match arms. These are our options, right? So if we are north, then a vertical counts, horizontal does not. Northeast does not. Northwest does not. South and south do, and starting and ground don't. So we're here, and then we to do, otherwise no go. Now we are going to need this value at some point. Like we need to know where we entered from. I'm not too worried about that yet. We will figure out how we're going to do that in a second. So for north position, that's just a bool. That'll tell us whether we need to look in the north or not. If we do, then we put north here. So I like the idea of these being options that we iterate over. Do we need to keep the direction that we are moving from in every single one? I think we do. I think we need direction like this. Wow, that was a really weird way to write that out. North, south, east, west. We'll grab debug and partial equality on this. So this could be the direction that we're coming from. And I think we could, no, we can't. I was going to say we could represent the pipe types as like a direction that we're coming from, a direction that we're going to, but that won't work because we could theoretically come in from either of them. So we've got south, east, and west and north, and we're coming from the north, or we are in the north, but we came from the south. So whatever value is here, southwest, southeast, or vertical, we will choose one of those positions based on the fact that we came from the south. We've got that position. And then I think we need to do this for each of them. We'll only get 2 values out of this in the end. Is this even abstractable? No, because we need to do that test. So grid.get is some and pipe is, if we even are looking south, then we need northwest and northeast. I can almost guarantee you that I'm going to look at this later and be like, oh yeah, it should be simpler to write this out than that. But I am totally okay with doing it in a verbose way and then optimizing later. So if we're looking to the east, then we need either horizontal and northwest or southwest, because we need that west connector if we're looking to the east. Same thing down here, horizontal. If we're looking to the west, we need the east position, either north or south. So now we've got north, south, east, and west. And I think we can actually get started here. I didn't add anything to this next positions in the end because we're just going to be able to take this and do it down here. Right, so next positions is north, south, east, west. There's an issue with north position for some reason. Oh, right, because this is an option ivec2 right now. Expected option ivec2 found option tuple. I started doing a tuple, didn't I? Okay, so north is coming from the south, south is coming from the north, east is coming from the west, and looking west is coming from the east. So this is an option of an ivec2 and a direction. And if we iterate over this and flatten it, then this type signature goes away. We need to iter over this at some point. So my thought process here is that we need to find the location at which both iterations are the same number. We start off not knowing the length of the entire loop. If we're iterating over the same position, that's our end condition, right? Trying to think about that. Because if we start and we go out one, as long as we always have two starting positions, I think that's true. Because they'll both land on the same one, unless they pass each other. But that would mean that there isn't a solution to the problem. So let me illustrate what I'm thinking a little bit. If J doesn't exist here in this loop, so it's F-7 pipe, F pipe, L pipe. If J doesn't exist here, then we are iterating from F to position 1, position 2, position 3. And this is 1, 2, 3. Then theoretically, if J wasn't there, 4 could flip. But then there would be no answer. So it has to be an odd number of positions. So 1, 2, 3, 4, like 0, 1, 2, 3, 4, right? Which is 1, 2, 3, 4, 5 positions from there. So once they are both processing the same position at the same time, that's when we need. So I think this is another chance for successors, honestly. Let's collect this for a second just to make this error go away. Yeah, we're iterating here over a direction ivec2. That's totally great. Unexpected argument, remove the extra argument. Oh, flatten doesn't take arguments, right? Because I was doing a filter map before. Okay, so we don't need to collect here. We got an item type of direction ivec2. That's exactly what we need. We need to do this iteration for both of these. And when they're both processing the same item, that's when we stop. So I think what we do is actually we zip here. So we'll map over this. We get our direction and our position, right? And then inside of this, if we do standard iter successors, we don't need to, I'm just going to call this tuple. We're going to start with tuple, right? And then we get from direction and the current position. And this is going to be an iterator. And this can just go forever. We're going to decide when this stops anyway. So given each of these, is that right? Is this supposed to, this is a tuple. So fill match arms, match from direction. This is all yellow because we're not really using it. So let's do let iters equals that. So we can have this, which is currently an iterator of item equal impl iterator item, which is a reference to a tuple, which I'm not sure we want a reference to a tuple for this. So I think we want the actual tuple. I tried to do cloned here to take care of the ampersand, but what I don't have is clone on direction. Do we need it on pipe type as well is the big question. Our test cases don't use the S's. Dang. I think the S is up there for that test case. Cool, cool, cool. Yada, yada, yada. We're not actually iterating over our iterators yet, so I'm not expecting this to succeed. Not yet implemented. Is that our process function? That is. Everything's great so far. Okay, so from direction. If it's north, we need the current position, right? So this is always going to work, but it needs to be let pipe type equals grid.get current position. Expect grid has valid values, or rather should not be asking for a grid position that doesn't exist. How's that for an error message? So we get our pipe type, we've got our from direction, and we've got our pipe type. If we match on both of these, is that going to be enough? I think this will be fine. I think this is just going to be a very large match is what this is going to be. So let's get these all in here. I think each of them has 3 options. So I'm going to take north 2, 3, 2, 3, 2, 3. 2, 3. And these all go in different directions, which is why I'm matching like this, or thinking about matching like this. So we've got all of these, and anything else doesn't matter. So I'm going to put these right here so that I remember them all. And I'm going to type this all at once. Pipe, type. And then if we're coming from the north, that means that we need to go, this pipe is either northeast, northwest, or vertical, which means we go east here, west here, and south here. And now we need to fill this all out. So I'm not going to talk through that as I do it. I'm just going to do it. So all of that. And if we do anything else, then we'll use the unreachable macro. We don't need standard on this. I copied that out of the docs. Unreachable. And we'll go should not fork off into nowhere, because if we're doing anything else, then we haven't considered the direction that we need to be going in, which means that it is either the starting position again, which would be weird and would be a loop already, should not fork off into nowhere or loop around again. So it shouldn't land on ground and it shouldn't loop around again. I guess fork off into nowhere is the wrong. Should not land on ground or loop around again, because we're expecting this algorithm to fail when they meet. So it should fail way earlier. This, of course, is going to be the direction we need to go, which is flashing giant red in my console because the return type is matching there. So always, 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 easy way to get rid of that is to just put to do right at the bottom of the block that you're working in so that the return type from whatever you're working on is dealt with. So this is the direction we need to go, right? And again, I'm being very verbose right now, but this is helping me in general think through what actually needs to happen. And we can always write a second copy that is more optimized, that has documentation, etc. So if we need to go north, we do the same thing we did up here. So all of these pluses, right? Plus this, plus that. So maybe this is a function that we abstract later. So these are all the directions we need to go. We have the direction that we are currently in. So currently in plus to go, and then we need to get the from direction, which is the opposite of this. So if we're already matching on that, I think we do all of our operations in here. So this is going to be a direction and then the current position plus our new heading. And this is going to be the opposite of wherever we need to go. If we need to go south, if we're going south, then we come from the north in the next tile, so on and so forth. This is probably a reference, and that's true. Cannot add ivec2 to shared reference to ivec2. And then I think that's just our return type, right? Is our return type not matching? It needs to be sum. So all of these are going to be sum. And theoretically, this runs until it panics. We aren't collecting it, so none of this is actually running yet. But you can see this is just a giant match block, effectively. So successors, map, tuple, successors. And now what we need to do for iters, I think we take what we have here and we take iters.next, right? We got path A and let path B, and this is option successors direction ivec2 tuple impl function direction ivec2 to option. It's the whole thing. We've got a temporary that's freed while still in use here. That is an issue. Where exactly is that? That's this vec. That is so easy for us to fix. There, now our vec is not temporary. A temporary is something that is kind of created in line. So for us, that's this vec of stuff that we are iterating over. I could into iter that, probably would also work. So let's do this, and then we into iter and kind of take ownership of that. But then we run into other issues. I think cloned is no longer needed there, actually, if we into iter. Iterator item is option direction ivec2, so we don't even need cloned if we into iter. So let's into iter, because that makes so much more sense for us. And then we're, what is it? Standard iter zip, I think is the right thing. So path A and path B. And then we find what? What do we find? I guess we find index here, right? And we're going to get A and B here. And we're going to do A.1 equals B.1, I think is our thing. And this is going to be an index, right? What is, okay, find index is not implemented for zip, which means that I named it something wrong. Let's go look at find. Find index is not here. Is that position? I always forget that. We're looking for position. Expected a closure that takes a single two tuple as an argument. That is easy to fix. We wrap a tuple around A and B. These then unknown fields because no field one on type successors. Interesting. We don't have to .iter these, do we? I think we do, actually. I'm being a little finicky here. We created a bunch of iterators in here that I'm not collecting that we are then trying to use together. Oh, you know what we need to do? We need to expect path A should exist because .next is an option. .expect, path B should exist. And now what we get is an iterator. And now everything would be fine. We don't need to .iter these because they are now iterators and not options. And our final position then is an option usize, expect to meet or should meet in the middle. So we clearly have an issue in our traversal here, should not land on ground or loop around again. I think that ground doesn't count, right? There is no pipe in this tile, therefore we cannot be there or do not want to be there. That seems correct to me. So I must have had a logic error in my match, which is, easy for me to think of because this is gigantic. Should not land on ground or loop around again. So we're hitting here. Let's do value, and we'll stick that in the error message, or the panic message rather. So everything that's a macro like this, right? All of these have the ability to use formatting. So in this case, we're using a debug formatter and we're passing value in. So this is entered unreachable code, should not land on ground or loop around again, south, northeast. And this is for case 1. So let's isolate this to case 1. Let's do part 1 tests, and then our path we get from this test here. So it's part 1 test process, case 1. That should run 1 test. It is running 1 test. If you don't want to write the whole thing, you can just test with case 1 as the name. And if that's unique, then it will run case 1. So we're running 1 test. We're panicking, should not land on ground or loop again, south, northeast. So we're coming from the south and we have a northeast tile. Is that accurate? Yeah. So we should never do that, which means I'm sending my things in the wrong direction. If we're coming from the north, so if we're going north to south and the pipe is vertical, then we need to go south. If we need to go south out of that pipe, then for the next position, we are coming from the north again. So I think that works. It looks like coming from the south on a northeast tile. So if we're coming from the south, right, that means we have to have been going north, which means that it had to have been one of these 3. It had to have been south, east, or west. Here we've got coming from the west. We go north. We've got coming from the east, hitting a northeast pipe. We go north. That seems correct. Then coming from the south, hitting a vertical pipe. We go north. That all sounds correct to me. So maybe what we do is, can we info this? And I'll use tracing info, and there's an issue. Value is not implemented for pipe type. So we're going to use the debug formatter there. We're going to use the debug formatter here. We're going to use the debug formatter here. I don't think we need it on everything technically. Yeah, we do need it on everything. So then we're doing rstest, right? I think we can do test log test rstest. I actually don't know the answer to that. I have never tried to do that. I wonder what the compatibility is here. If you would like to use another test attribute for your test, you can simply indicate it in your test's function attributes. Okay, so we should be able to just do that then. That seemed like something that should exist. I wasn't sure if it did. So we've got test log test, which now should be running. And of course we need to rust log info to get the information we want. And now we're getting processing steps. So from direction, it looks like we didn't actually process all of the input there. No, wait. Yes, we did. Sorry, we need to skip the input and process because I don't want to see all of it every time. And we can dump this out once here instead. But I wonder if I can get it to... Okay, so now we know which one we're looking at. I will look down at this down here to determine. So from south, so we're starting here, right? From south, current position 1, 2. Oh, you know what? I think map XY adds 1. No, it's -1. Okay, we do turn it into 0. But I was right. This is one indexed, and I'm glad I left this comment here. So we've got current position 1, 2. So 0, 0, 1, and 0, 1, 2. So this is the vertical pipe here. And then from west, 2, 1, 0, 1, 2. That's the horizontal pipe. That looks correct. And then from direction south, 1, 3, 0, 1, 0, 1, 2, 3. So that's the L, which is northeast, but the from direction is wrong. So the from direction for coming from south into a vertical pipe. Wait, we're not coming from south. We're coming from north. So my initial is wrong, is what that is. So our initial direction, right? These directions aren't where we're going. They're where we're coming from. Did I mess up? North position comes from the south. South position comes from the north. But you know what I did? I flipped them. Negative is up in the way that we currently have our grid. That is also true for east and west. west is negative, east is positive, but north and south are flipped, I think. So that means that our other thing here is also wrong. So this is negative and that's positive. And then do we get to our final position? Final position is 3. 3 plus the starting position is 4. That is the right number. Okay, so let's go back to our full tests here. Let's get rid of the info there. We're still doing part 1. So now we have 2 failing. And this is final position +1 for the initial starting position, 2 string. Okay. And now we have 2 passing tests. Wonderful. So we can run 10, 66, 90, and that is the correct answer. So part 1 is done. So just working through it for part 1, bit of a long one, but really just very mechanical. I'm sure there's ways that we could do this faster. I'm sure there's less code we could write. So part 2. Part 1 took us quite a while, but part 1 was very mechanical. Let's see what's up with part 2. We quickly reached the farthest point of the loop, but the animal never emerges. Maybe its next is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for a nest, you should calculate how many tiles are contained within the loop. The above loop merely encloses 4 tiles, 2 pairs of dot in the southeast and southwest. Yikes. Middle tiles are not in the loop. Figure out whether you have time to search for the nest by calculating the area within the loop. How many tiles are enclosed by the loop? So my initial thought is pick a place outside of the loop and then iterate over everything, filling everything. So the only way to pick a place that is guaranteed outside of the loop is to pick a place next to the start. If we pick a random place, it could be inside or outside. So we start by running the algorithm we just did, except instead of stopping and returning the furthest position, we keep track of everything. So I think that I'm very happy, actually, that we did successors here, because I think that gives us access to everything. So let's start by copying this into part 2, right? Part 2, I don't know that they give us the answers for the ones we had originally. They do give us a new one, and we do have to determine how many tiles are enclosed. So it's going to be this, and the answer is going to be 4. Do we have other examples? Here's a larger example. So let's take this. Yikes. We need to account for every single position on the board. The only saving grace that we have is that the loop is closed. So it has to be within the bounds and it can't overlap itself. So if you're inside and you're touching the outside, actually, how do we even? This one is outside the loop. How would you even tell? We can do the whole loop, but there isn't even a guarantee that if a place is enclosed by the pipe, that it's inside. I wish this highlighted the path. This is all outside. So the hard part in my mind is, right, this square on the bottom right here and this square on the bottom left both have the same initial structure as this middle. So this middle is some dirt blocks and then like not any space between the 2 points, but theoretically that means it's outside, whereas these are inside. I feel like there's some kind of algorithm where if you cross a line, then you're inside, and if you cross another line, you're outside, and if you cross another line, you're inside. If you cross another line, you're outside. But that relies on what? Needing to start outside. I feel like that's the answer. Does that work in general? I wish this one had its path shown. It would make that detection so much easier. Is this just the pipe? This might actually just be the pipe. Okay, so then let's apply that heuristic, right? So we start on the outside. Let's say we start top left. We start going down, right? We hit a pipe, we hit another pipe, we're back outside. Okay, we hit a pipe, we're inside, we hit a pipe, we're outside. Okay, so let's try to find outside, hit a pipe, inside, outside, inside, in, and then it doesn't matter for the rest of the line. So if we start here, then the next one is in, the next one is out, the next one is in, the next one is out, next one is in, next one is out, next one is in, next one is out, next one is in. These are all in, next one is out, next one is in. That doesn't work. Oh wait, oh, these are all in, next one is out, and then here it would be next one is in, wouldn't it? So that would be in technically. It almost worked. Unless I messed up my little reading. So if we're out and then we are in, out, that works. I wonder if it breaks if there's a block of it in the middle. So if we're out, next one is in, next one is out, next one is in, we are in, next one is out, next one is in, we're in. So did I just do this one wrong? So we are out, next one is in, next one is 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 out, next one is in, we are in, and then we're out, and then next one is in, and then this one is in, and then this one is out. Is that the way that works? So if we are in, then the next one is considered out, but otherwise it's that flip. I think that's the algorithm. I don't know where I remember that from, honestly, but I think I'm going to try that. That does mean we need to know where all the pipes are, right? All right, I'm not sure how long I just waited. There was somebody playing copyrighted music outside, so I might have to cut something I just said off. But basically, there's some algorithm, and I don't know where it's from. I have some like outside brain thing that it came from MS Paint, but this is flood fill, and flood fill is not, I don't think, what I'm thinking of, because flood fill is just expanding from the center. I don't know. It's not flood fill because flood fill is a different algorithm. I cannot remember for the life of me where I came up with what I just came up with. It does require, I believe, that we have all of the pipe locations, because the pipe locations are the only things that matter for this. Also, if you know of where this algorithm came from, let me know in the comments, because I can't remember. It was stuck in the recess of my brain somewhere. So we're going to get rid of, I guess we have two options here, right? So we can do the one with just the pipe, and we can do the one with, wait, in this larger example, 8 tiles are enclosed by the loop. Wait, is there a different, is this a different example? It is a different example. Okay, this is another example, and that is 10. Okay, so those are all the tests. I think we'll just run the tests here. And we did all of this work, right? But we need to do more. So instead of getting the position, right? We don't want position here. I mean, we do want position here, but like, you know, we need to collect all of the pipe locations. So we can let one of these go, honestly. We don't need both of them. Both of them is fine too. So what do we do? A while let here? While let, I guess we could just loop too. Looping would probably be the easiest thing. So we do this. We don't need position. We do need this check, so I'm going to comment it out. I needed to make sure that we could use break in while let if I was going to do it this way, because we are going to need to break at some point. And I don't use breaking out of while let very often. So we can do while let, what, sum AB? I don't know. Let's call this path A node and path B node. And this is equal to this iterator that we just created with this. We don't need final position to be equal to this. That looks like it doesn't work. So what is our issue? We need to, what, iter this? We need to into iter this? What's your deal, compiler? What do we actually need to do? Oh, right. Let's do this. Let's do let mute zip it equals this, right? And then while let this equals zip it dot next, then that is now has to be a sum, right? And now we're good. I was just trying to do too much on one line. That's all. So all of this together, final position is the wrong thing. So we're going to do this. And what do we actually need at the end? Count of internal nodes or tiles or whatever. So path A node and path B node, right? This is a direction and an ivec2. We don't care about the direction at all. What we do need is the pipe locations. And what I want this to be is a lookup table for an ivec2. I guess this can be a hash set, right? The hash set, we don't really need the values. We just need to know if it is a pipe location. So when we have each of these, we're going to do path A node dot one, which is our ivec2. And we're going to insert that into the hash set. Rust Analyzer not helping me out right now. Insert, I think it is. And we're going to insert path B node, right? And we can just leave those inserts every time. And then if path A node equals path B node, and it really doesn't matter that we just inserted those because it's a hash set and we need to at least insert once. So we will break out of that at that point. Let's debug the pipe locations, that length. This should be -1 right now. So case 2 has 5. Where's case 2? That's not right. No, case 2 has 139. I'm not counting those. Let's go for case 1. Case 1 has 45. Okay, I'm going to count 45 numbers now. I'll be back in a sec. Okay, I'm back. I counted every single one of them, even though it is exactly the same on both sides and I could have counted half. I don't want to talk about it. But that is the right number of locations. So 45 is correct here. So what we really need then is our starting position, wherever we got that back in, 1923 here. We need to get that starting position. And we're going to start it off with that. Done. And now we have 46, which is the right number. Cool. So we have our pipe. I think we need the ground tiles. So we're filtering out the ground tiles here, right? And I don't think that we want to do that right now. So let's not filter. Let's just return some here. And I believe that that doesn't change our calculations. It doesn't really matter, right? Because all we're doing here is doing a little bit of extra work to find the starting position, and then we're indexing in. So it shouldn't matter. And we should still get 46 out of this other one. I removed the debug though, so it doesn't matter. So we have all of the pipes, we have all of the tiles, we have the grid, and now we need to implement our little check algorithm. And I think what that means for us is we iterate over either each row or each column, and we do our little, like, if we cross over, the next one is in kind of thing. So I'm going to create another enum up here because I'm just an absolute monster for enums today. And you can either be in or you can be out. And we're going to use that. We do need the full size here, which I think we can just get, right? Input dot, well, I can think of doing this two ways, honestly. We can either take the input, right? Which is a grid, one of these grids, and we can get the length of the first line, which would be what? Position, iter, position, I guess not iter, but cars, right? So let total length equals input dot length, let line length, or I guess what, row length equals input dot cars dot position c. And on my computer, this is going to be c equal, or I guess we could do what is new line. Is that in here? I know that I'm going to have new lines. I know that this could cause issues on, you know, Windows or whatever. So read line treats this byte as a new line, and then I assume just chops off the other one. So I'm a little concerned about how that's going to behave on Windows. I don't think I'm going to care right now. The obvious answer to that, though, fixing that problem for me right now is lines.next.unwrap.cars.position. We don't need dot position anymore. This can just be dot length. And then we don't need to explicitly match on any line. I guess we don't need dot cars either. So if we debug this out, which is kind of ridiculous. Did we fail somewhere I didn't expect to fail? Case 1, panic. Count of internal tiles not done yet. Oh, because my to-do is above. Well, don't forcibly panic your program, kids, and your program won't panic. Okay, so case 3, 209, row length 20, column length 10. I guess the column length doesn't really matter though. I do feel a little silly right now because why am I calculating this, right? Like we don't need the total length. We have lines, right? If we do lines.enumerate, .map, line, line.cars, .enumerate, .map, what is this going to be? I, N, or let's say Y, X, and then the character we don't care about. Yeah, line is usize stir. So this actually is Y, and then this is X. We don't care about the character. We only care about XY. And all we're doing right now is debugging. So usize is all of that. And I'm just going to debug that and see if it gives us our grid that I'm expecting. Let's narrow down to case 1 again so that we can actually get an actual read of this. So what do we have? We have 0, 0, 1, 0, 2, 0. So we are in the row. So we're going to do this by rows. And for every grid location, we are going to check if the current one that we're processing is one of the pipe locations. If it is, we're going to flip the in out. And if it's not, we're going to leave it. And if we're in and we're on ground tiles, then we add that number. And if we're out and we're on ground tiles, we don't. And that's what I'm going to do. I do not need to collect this. I did anyway. I'm going to leave it and I'll come back at some point because this is just an absurd amount of code anyway. I'm just kind of leaving stuff and I'm going to deal with it later. I'm sure there are shorter ways to write what I'm doing, but I didn't even know where we were going. So we're going to iterate over the grid positions. I guess it doesn't matter here. So I'm going to have that be a result. And then for each of the grid positions, cars enumerate map. For XY in cars enumerate map, we are going to we're going to start out, right? So let mute status equals status out. That's where we are. We start out every line. And then I guess we could filter map this. That would probably be I'm not going to say better. Better is the wrong word, but that would probably be the more straightforward way to do this. And then we count the end. So we're going to filter map and we've got our status. I guess we only need filter here. So let position equals ivec2 new, right? This is our position, our grid.get position. We're going to always expect a valid tile. Is the grid the right thing to do here? Yes. I'm going to include this as a debug check. We don't actually need to do that, because what we need to do, what did I call our hash set? Pipe locations contains position. If that's true, then status, we match on status, and status in becomes status out, and status out becomes status in. Position needs to be a reference. These are U sizes, so they need to be cast is what we'll do to I32s, I believe is what we're working with. Or is that wrong? Are we working with I64s? No, that we just need to get the values. Okay, so I32, grid get position, status. This needs to be not something that returns. I guess if it's a pipe location, it's false. Otherwise, match status. And if we're in, true, and if we're out, false. So what we're doing here is we're filtering each of the positions. We get the position from our enumerations here, which is great. There are more succinct ways to do that. I think a Cartesian product would have been better for just generating that list, but we're going to do the enumeration. It's fine. If pipe locations contains position, status changes. So if we land on a pipe, then the next position is going to be either in or out, but we don't keep this one, right? We don't count pipe tiles. Otherwise, we either keep it if it's in or we don't keep it if it's out. And either way, we don't change anything. So our status here then, this is going to be what, a vec of I32s at the end of the day. Item change to unit here, that's this, right? We return that count for each row, and that will be U sizes, I suppose, because it's the count. And then that debugs result, and we get 1, 1, nothing, 4, 0, 0. So we've got nothing here. This claims 1. I think we're miscounting here. This claims 1. We're also miscounting here. So what should we be doing? We're out. There's ground. We hit a pipe. Next one is in. Out, in, out, in, out, in, out, in. So maybe that doesn't work. Let's see. So we start out, right? We hit ground. Ground is out. We are out. Next tile is in. Next tile is out. In, out, in, out, in, out, in. That doesn't make sense though. So I wonder if the position matters, right? So if we get here, right? The next one is in, next one is out. But because this is a horizontal, maybe it's just in. Next one is in. All of these, next one is in. Or is this just one line? So we're out, next one is in. This is all in. Then we cross the line again, right? So what counts as a line cross is really what I'm asking. It's an algorithm for polygons. We don't have a polygon. We have like this. In computational geometry, the point and polygon problem asks whether a given point lies inside, outside, or on the boundary of a polygon. Special case of point location problems, and finds applications in areas that deal with processing geometrical data, such as computer graphics, ray casting, and angle summation. Yeah, one simple way of finding whether the point is inside or outside a simple polygon is to test how many times a ray, starting from the point and going in any fixed direction, intersects the edges of the polygon. If the point is on the outside of the polygon, the ray will intersect its edge an even number of times. If the point is on the inside, it will intersect an odd number of times. That's the key that I was forgetting, the even versus odd. The status of a point on the edge of a polygon depends on the details of the ray intersection algorithm. Okay, so I think we have a custom status for the edge. The edge feels throwaway to me. So in that case, let's do this. Let's create a new test. And I'm going to create a new function called pip, and it's just going to work on one line. So maybe we'll call it pip line. Pip line does not exist. So we're going to do fn pip line, takes an input that's a string slice and returns us a u and an I32. U and I32. All of these need to be examples. Okay, so we've got all of our lines set up. We need this one to return 4 and all of the others to return nothing. So this is going to be what? Test pip line. And this is just going to be a new thing, new start outside of our other function, because our other function is so big. So pip line. So for C and input dot cars, right? I guess we could fold this, but let's do this in a very basic way. So let's score equals 0 and let crossings equal 0. So we need to handle dot S, pipe, F7, L, and J. So pipe, definitely. Dot, definitely not. S, maybe. F, all the others, maybe. So if crossings mod 2 is 0, score plus equals 1. Right? If the point is on the outside of the polygon, the ray will intersect its edge an even number of times. So that's outside. So if it's not equal 0, if it's not even, if it's odd, then we increase score. We aren't handling minus here, which is important. And we return score at the end. Score by default is 0, so I'm not surprised that all of the ones that are 0 run. 9 tests run, 8 passed, 1 failed, 5 skipped. So the question then, pip line case 6 is the one that failed. Interesting. So if it's just pipes, that works. Case 6 is, which case? Yeah, Rustlang info is running. Great. Let's instrument this. Classic. That is exactly the line that we need to fix. So the question becomes, what do we do with it? If it's only pipes, this doesn't work. We need it to be even. So maybe we don't count corners. If we don't count corners and we have an odd number of dashes, then we fail something like this. However, if we, maybe that's what it is. Maybe that counts as 1. No, it can't count as 1 because we have 2 pipes, right? We have pipe, then if this counts as 1 and pipe, then we're odd and we're inside. I feel like there's some little piece of inside I'm missing, but I'm so close. Oh no. I don't like this at all. So I kind of just like hacked through it and found a bunch of solutions, or I guess not solutions, right? But I kind of just made some guesses about which things qualified as crossings. And with that information, I was able to determine if you count S pipe, F, and 7, but not LJ or dash, then everything works. So there's something about maybe only counting 1 crossing every time it hits a pipe, and it just so happens that you need either an F or a 7. I don't know. We've got LJ here. It feels sketchy. It feels sketchy, but I'm going to go with it. So S pipe, F, and 7. So if the pipe location that we're on is one of these 4, flip it, otherwise don't. Okay, that still doesn't work. The logic is a little bit different. Oh no, actually that works for this. Am I just not? Oh, they're all failing because I didn't return the value, y'all. We could have actually had the solution already. Okay, let's check our, oh man. Okay, so that works. I don't know why. I guess there's just some like arbitrary rules for this algorithm about whether it counts as a horizontal or not, but at least I have it documented and at least we passed it. And we did use like the right graphics algorithm for this, which I'm pretty happy with. It took me a long time today though. This one was tougher for me than it usually is, even though I kind of had the right idea. And part 2, we passed. Okay, so that was it. All right. That's going to be a long edit. I'm not going to lie. Okay, let's benchmark it for kicks. I am not really proud of this code, I'm going to be honest. I am proud of the fact that I recognized this algorithm because I've been working on graphics knowledge all year. And the fact that this algorithm stuck in my head well enough to pop up on a random advent of code question, I'm really happy with. But otherwise, this is the first time I've ever implemented that algorithm. And I think doing that algorithm on an advent of code problem made it harder because of the horizontals here and the edges having like weird rules. Like there was no, I think if I was writing this for a graphics program, I would have had more clear distinctions about whether I should or should not count that edge. I could either make that decision or not, write some extra test cases, etc. But this being an advent of code problem, the rules feel a little bit more arbitrary than they otherwise would. So our benchmarks are slow today compared to every other day. I'm not really concerned about that right now. I might refactor it to try to run it faster. We'll see. We've got 2 milliseconds for part 1 and 3 for part 2. I assume that our DAT today is going to be some of the worst heap profile usage that we've seen so far. Actually, not as bad as I thought it was going to be. 3 and 4, yeah, 4 there and basically 4 here, so an extra 200K. Not as bad as I thought it was going to be. Are you excited for this deep dive on 200 lines of code? All right, so part 1, mechanical, but relatively simple. The parser is very verbose. I really want to rewrite this if I have some time, but it's very straightforward, so I'm going to leave it. So for part 1, fairly mechanical, took a while to write out, but overall, we have a starting position and we need to iterate in 2 directions to find the furthest position. There will, because of the way this is set up, always be a furthest position. So we don't need to worry about things like if these 2 sort of iterations cross each other and don't land on the same node. So this is first a parsing problem. We need to get the direction, or we need to get the positions of everything in the grid. We need to get all of the values and which things they connect to. All of that is fairly verbose and mechanical, but not terrible. So we have this parse grid function here. We're using the nom locate types. Let me bring this up as I talk about it. So nom locate is a library that we used on day 3 as well. So if you want more of a background, watch day 3. It gives us this located span type that keeps the location of the parsed values, which we can then use to construct the grid positions. So our parser then is a many one for every single character that we're going to get. We map over that parser to add the location information, and then we transition that into a struct. This is pretty verbose. We don't need to do everything this way, but as I was working through it, it really helped me to have the kind of more verbose nature here. So we have this repeated like 9 or 10 times for every character. We transitioned those through that map into a pipe type. So what we end up with is the match with the location information as well as the type we parsed out. So I kept all of the information. That's why this looks pretty verbose. We used the with xy function that we wrote on day 3, so there's more of an explanation there. But basically, because we used this span input type with nom, we get the ability to just grab the column and grab the location line, which are the x and y positions. They are 1 indexed according to nom locate, because this is usually used with source code. We store that data in the extra storage inside of the span, and I created an extra type to keep track of a located span with an ivec2 in the extra type. So parser is fairly verbose today, but it's fairly straightforward and we could probably bring it down a bit. So now we have everything that we parsed with the grid and its positions. Our first goal is to grab the start position. We built everything up into a B tree map, so we can just iterate over that and look for the starting position. We could have also just kept this around when we did the parse, but I chose to do it this way because this was more straightforward. And honestly, looking at the problem, and if you've watched the videos thus far, you'll know that I didn't quite know where we were going when we started. So I tried to keep around easily deletable segments of code where if I wanted to go back later, I could just delete this and get it from somewhere else, and it's not a big deal. So then we need to kickstart our algorithm, and the S in the grid, if we go down and we look at these grids, the S in the grid could connect to any 2 locations. This is specific to the advent of code input. It has to be 2 locations because there have to be 2 paths to get to the furthest end of a loop. We don't know which ones they are yet though. So we try for north, south, east, and west in the same exact way. For each of these, we are just checking to the north, south, east, and west using an ivec2, getting it from our B tree map. If it exists, so this is sum and is a function on option. And we can say if the option that we have, if the value that we have is a sum variant and that value inside of it matches some predicate, some test that we're going to run, then this returns true. Otherwise, it's false. So in this case, what we do is we test to see if the pipe type is a corresponding pipe or a valid pipe to connect to the start. So if we're looking north, for example, a vertical pipe to the north of the start connects to the start. So does southwest and southeast, because that means the tile to the top has a connection to the south. If this is true, then we return a direction here alongside that position. The direction is where we're coming from. So north is the tile that we're going to, and south is from the view of this tile where we are coming from. So if we're going north, we get to the north tile, and the north tile thinks we came from the south. We need to keep this value around so that we know where to go next. So once we do that for each of the positions, only 2 of these positions are going to be valid. Only 2 of them are going to be sums. So we turn that into an iter, we flatten it, flatten gets rid of the none values and unwraps the sums for us. So now we have 2 of them. At this point, when we're mapping, we have 2 of these values left. We don't know which ones, which is why we kept the directions around, but we have 2 of them. We then use successors to create an iterator that iterates over the directions of this pipe. We talked about successors in the day 9 refactor. So if you want to learn more about that, go watch that video. We give successors the initial starting value, which is this tuple that we created. It's the direction and the position. And then we have this from direction and our current position. We need to get the pipe type from the grid, which should exist because we are only working with valid grid locations. If we don't have a grid location that is valid, then we have messed up somewhere else and we need to panic. Given the pipe type for the current position that we're at, we have the direction we're coming from and that pipe type, which together, if we match on them, tells us the direction to go in. Given a direction that we need to go in, we then know which direction that tile is going to perceive us coming from, as well as that new tile's position. And then we just keep iterating and iterating and iterating. And this keeps producing those and producing those and producing those. And it doesn't worry about whether it's going to overlap with the other iterator. It doesn't worry about anything. It just keeps following that pipeline forever, producing the next value, producing the next value. So what we get back from this map is actually an iterator, which means that we need to pop off the next two iterators, right? So iters here is an iterator of iterators. So we need to get those two and zip them together so that we can iterate over them at the same time. Then we want to find the position at which they both meet on the same node, which as you can see here is not a lot of code. So we're taking both of those iterators and we're moving over them at the same time. And then we're getting the position at which they land on the same node at the same time. That position is the distance that we needed to go. So we need to add the starting position to that because we didn't have that when we started iterating. We did that beforehand. So +1, and that gives us the distance to the furthest point in this grid. Part 2 is basically the same code. So same parser, same pipe. We calculate the start position. One thing that we did do is we don't filter map out the ground positions anymore because we need to count those to score later. So we do the same north, south, east, west for the initialization. We still get those iters. We still do the successors. And then once we have this zipped together iterator, we let that run in the same way that it ran in part 1, and we build up a hash set from all of the positions that we iterate over. We do that by using a while let. So this zip of these two iterators will produce a tuple of those two tuples. So a next from one of them and a next from the other one. We insert both of those into a hash set. So a hash set, as you can see on the left here, is basically a hash map where the value is unit. So this will give us a unique or a uniqued set of ivec2s, right? So it doesn't matter that we've inserted twice here, especially for that last node where they're both on. It doesn't matter because we will only have one of those values in the hash set. If we are on that end node, we break out of the while loop and our while loop is over, and pipe locations includes the location of every pipe in the loop. This is where part 2 really starts. What we do here is we implement a version of an algorithm that is loosely called point in polygon. And point in polygon is a computer graphics algorithm that I either picked up over the last year from working with Bevy or doing ray casting or ray tracing or something like that. At some point I found out about this algorithm, maybe when I was working on, Rust, WGPU, web stuff in the browser, I forget. Stuck in the back of my brain, this is the algorithm that we're implementing. This algorithm basically says if we cast a ray, we can count how many times that we cross each of the edges. If it's an odd number of crosses, then we are inside whatever shape this is. If it's an even number of crosses, then we are outside of this shape. So all we have left to do is figure out which of these characters counts as crossing and which doesn't. The big hang up here, of course, because there's always a hang up at some point in Advent of Code, is defining what happens if we are on an edge. The way we chose to do it, and this was a little bit through trial and error, is I wrote this additional function here with some additional tests. We didn't use this code specifically, but this code was very useful as a separate thing to figure out what counted as a crossing. And you can see here the algorithm at play. We keep our score and we keep the number of crossings. For every character in a row, we iterate. If we're on a ground piece and we are inside of the shape, then we add 1 to the score. Otherwise, if we are on a pipe that we should consider crossing, right, one of our line crosses here, then we add that to the line crosses. And if we are on one of these other shapes, then it doesn't count. Why is this the grouping of F7, L, and J that counts and doesn't count? I'm not quite sure. But building out this extra test made it so that I was able to figure it out. We had the pipes, we had the S, we had the dots. We just needed to figure out what counted as a crossing when it came to the edges. And that, of course, is custom to Advent of Code's implementation, as it would be custom to whatever ray tracing or ray casting algorithm you were using for whatever application you were using. So this is just how Advent of Code decided it would work, and we figured that out. So this is that algorithm as implemented in our program, right? So we did all the other work, and then I created another enum called status, which is either in or out. I chose to not use the crossing number, although we could definitely use the crossing number. And I might do that in a refactor anyway. So we iterate over each row. We do that same cars that we did. And here we're filtering out anything we shouldn't count. And then we're counting the rest. So instead of maintaining that score variable in the other function, we're just filtering out ones that shouldn't count. We do the same thing. We get the position, we get the pipe type. This actually next pipe type no longer matters. That was an earlier attempt piece of code. If our pipe locations contains the position, so this is our loop. These are all the locations that we stored from our zip iterator. If this hash set contains the position that we're currently looking at, and that position is one of the 4 that we identified as counting as a crossing, then we flip the status to either in or out of the shape. And we return false because these don't count when it comes to being a thing that is inside. Otherwise, we return either true to count this ground piece or false to not count this ground piece. And that's it. We count all of that and we return the result. So overall, the algorithms used in this code are not terribly complicated, but it was a lot of code for me today. It was especially a lot of code because I didn't know exactly where we were headed when we started, and I didn't know what part 2 was going to bring. So I decided to do everything in a little bit of a verbose way. And I think this could be simplified, but I am very happy with having solved it. So I have a feeling that this is going to be a tough day. And it looks like we have some people who are either taking longer on part 2 than usual or haven't tried it yet. So I think that's panning out to be true. Of course, our top 3 are still our top 3. I think our top 5 have actually been our top 5 for quite a while. So Greg and Samanthingamajig, congrats on being in the top 5 for so long. And otherwise, I'm going to go edit this video, which is going to take me forever because, ooh, wow, it took me a long time to do today. So I hope you enjoyed this. If you have any questions, leave them in the comments. I can definitely try to refactor this if people are interested in that. This code is verbose, but it does get the job done. So have a great rest of your day, and I'll see you in the next one.